Okay, so Mrs. Collins asks her class to graph the function g of x, and then there's the function. Use your knowledge of transformations. Describe how each part of g of x, highlighted below, will be affected by the parent function f of x equals x squared. And then we're going to complete A through C. Okay, so they give you f of x. It's graphed for you right here. So this here is f of x. We're going to, eventually in a little bit, we're going to graph this g of x. Okay, now, where's this one? Okay, let's just write a few things that we know. Like this 2 in the very front. We talked about what this a value does. What does it tell us if it's a 2 in front? Just from what we learned yesterday about it. This is the a value. What's it going to do? Is it going to, what knowledge do we know without even graphing it? Because this is a positive number. It's going to open up. How about the fact that it's greater than 1? It's a 2, right? That's greater than 1. What did that do to our graph? It's going to stretch it. Yeah. So let's write that down. It's going to open up and stretch by a factor of 2. Okay. Now this 3 here. Remember we talked about that more so like on Monday. This gave us a shift. Yeah. Yes. It's going to move along the x-axis. So is it going to move 3 spaces right or left? Right. Okay. And then the last thing is we have this constant plus 1. That's also going to do a move, right? Yeah. Yeah. We're going to go up move up 1 unit. Okay. So now they're asking us, I'll use a pencil in case I make a mistake and then I'll darken it in. Sketch g of x. We really have everything we need. So first of all, we're going to move, like we said, 3 units to the right. 1, 2, 3. And then 1 unit up. So from our from where f of x is, 3 units to the right, 1 unit up. And then we know this is going to be stretched by a factor of 2. So instead of going, if you notice, on f of x, it moves over 1, I'm sorry, over 2 and up 4. This is going to be slightly different. It's going to move over 1, 1, and over 4. So it's going to do something like this. Just didn't want to make a mistake. It's going to stretch it like so. You probably could do a better job than I can right there. And remember, we know it's going to open up. Okay. So just by the knowledge we know, we can pretty much graph anything we get here. All right. So we sketch the graph. Find the vertex. What's the coordinates for the vertex? 3, 1. Where do the values of the vertex appear in the equation? Okay, let's take a look at the equation. Do you see the numbers 3 and 1? Yeah. H equals 3 and K equals 1. Right? In the equation. So basically, what we have here is the vertex form of a quadratic equation. And there's 3 numbers that we always look at: the A value, H, and K. Okay. So whenever you write an equation in this format, you're given H and K, which are the vertex. So H comma K is always going to be the vertex for that equation. And the value of A determines, well, what is A going to tell us? Yeah, kind of like the slope, but we call it the stretch maybe, or whether it's stretched or widened. Anything else? What if it's positive or negative? Yeah, how it opens. It either opens up or down. So the 2 things that's going to tell us is which way the parabola opens. So it determines which way the parabola opens. It opens. And that's either up or down. And number 2, if it stretches or widens. Okay. So here's a little exercise, guys. Let's write down the vertex for each of these. So let's do the first one together, and then I'll let you do the other 2. Okay? So the first one here, we have this this function f of x, and it's in vertex form. So where is the vertex for this parabola? 5 and 2. Remember, if it's minus, it's actually a positive vertex number for y, x. Okay. Minimum or maximum. Here's where this comes in. Now, it's going to be a minimum. It's positive, right? So it's going to open up. It's going to open like this. Because the A value is positive, it's going to open like that. So that means the vertex is going to be the lowest point. It's the minimum. If it would open down, then it would be the maximum. Okay? So I want you to fill in the other 2. Find the vertex and min or max for the other 2. Give it a try. This is what I got. Hopefully yours matched up with mine. So for r of x, this is plus 6, so this has to be a negative 6 for the h value. and then minus 4. This is the a value is positive, so it opens up, so that's a minimum. For y, this function here, that's going to be 10, 0. There is no constant, so it's 0. So that means it's going to be somewhere on the x-axis, the vertex, and then it's going to open down because it's a negative 4 for a, so it's a maximum. Any questions? Okay. Let's move on to something else about these this vertex form. Functions written in vertex form can be converted into standard form. Okay, so guys, we're gonna want to convert these from this form to standard form. Let me remind you what standard form looks like. That's standard form. Okay. So what we want to do is rewrite our equations that are in vertex form into standard form. And all it is just doing a little algebra that we've already learned. So let's practice it, okay? So if this is in vertex form, we want to get everything outside parentheses, combine like terms and all that. So the first thing I want to do is I don't want x minus 4 squared. So either you remember how to square binomials, or you could just do x minus 4 times x minus 4. Yes. Go ahead.
Do we square each one individually?
Well, you square x minus 4, the whole binomial. So one way to do this is x minus 4 times x minus 4 plus 5. The other is, if you remember the way to square a binomial that we talked about a few weeks ago? I'll remind you. Maybe it'll come back when we do this one. So now we can either use the FOIL method, any method you like, but we have to multiply these together. So I'm going to do first outside, inside last. So this is going to be x times x squared. Then I got to multiply x times minus 4. Keep that in your head. That's negative 4x. Then negative 4 times x. So negative 4x plus negative 4x is negative 8x. And then you multiply the last. Negative 4 times negative 4 is plus 16. And then plus 5. And we're almost there. The only thing left to do is combine your like terms. 16 and 5. So that's 21. So the answer is x squared minus 8x plus 21. That's in standard form now. Okay. All right. What's our vertex though? 4, 5. And when they ask for this in standard form, it's x squared minus 8x plus 21. Now, real quick, guys, when you want to do the shortcut, when you're squaring a binomial, remember, you square the x term. That's how we ended up with this. You take the x, the a and the b, these x and negative 4, multiply them together. That's negative 4x. Then multiply that by 2. That's how we ended up with negative 8x. And then finally you square the constant term. Negative 16 squared is 6. Negative 4 squared is 16. That's how we ended up with that. So that you can do all that in your head, and then you get this. We'll practice that on this one. Okay? And then you just combine. So let's try that on this one. What's the first thing we have to do for g of x? If we want to write this in standard form, do we distribute the 3 or square? Can't distribute first. Think of order of operations. Yeah, do the squaring first. Think of order of operations. Yeah, before you can distribute, you got to square it. We are going to distribute eventually. Okay, so first step is going to be to multiply these together. So let's see. X times x is x squared. What's x times 2? 2x. Um, Eileen, close it. Close them up. X times 2 is 2x. Multiply that 2x times 2. The middle part is 4x. And then finally, square the 2. 2 squared is how much? There. We just squared x plus 2 squared. Okay? That's the shortcut way. If you still didn't catch it, then you do x plus 2 times x plus 2 and do first outside, inside, last. Okay. Now we distribute. So now we multiply by 3. So that's going to be 3x squared plus 12x plus 12. Okay? So there it is in standard form. Let's write down the vertex though. What's our vertex value? Negative 2, 0. And in standard form, this is 3x squared plus 12x plus 12. Okay. Any questions? Let's try the last one. Quick reminder, guys. This is a negative 1. If there's a negative there, that's a negative 1. Okay? So I'm going to keep that negative 1. But let's square x minus 1 squared. Let's figure that out. Okay? So x minus 1. See if you can. What's the first part? X squared. You take the x and you square it. X squared. Okay. What's the middle term going to be? Minus 2x. You take the x and then minus 1 and you multiply them. X times negative 1 is negative 1x. Then you multiply that by 2 because you get 2 of those. Minus 2x. And then you take your negative 1 and you square that. 1. And it's positive 1, so plus 1. And we still have a minus 8 behind that. So first thing you do is square your binomial. Then you distribute. So distribute your negative 1. Negative x squared plus 2x minus 1. And then you still have a minus 8. And the last thing you do is you combine your like terms. If you have any, and we do, we have negative 1 and negative 8. That's going to make negative 9. Okay? So we have everything we need now. We have a vertex. What's our vertex value? 1, negative 8. And then we have negative x squared plus 2x minus 9. Remember, I combined the negative 1 and the negative. Okay? All right. So here's a question for you. How could we prove that the vertex form and standard form of each of these functions? So how do we know that this original vertex form and this standard form would be the same equation, just in a different format? I'll give you a hint. What if I graph both of them? What should I expect to see if I graph both of them? Same thing. So maybe I could go into Desmos and check. So equivalent. Let's say that we can graph both, and I invite you to do that if you have some time. graph both equations on a graphic calculator, or even better, in Desmos. To verify they are identical. All right. Okay. So that's one thing we're going to do. Convert vertex form equations into standard form. The other thing we're going to do is on the other side. You guys ready? All right. We're going to write equations using vertex form. So a vertex form equation, a vertex form can be used to write a quadratic equation when you're given the vertex and another point on the graph. Use the steps described in the box so we can do this. Okay, so suppose we know where the vertex is, what the coordinates are for the vertex. And we also know some other point on the graph for that parabola. This is what we're going to do. We're going to plug in h and k and the values of the given point into this. So we're going to take these two values, h and k, and whatever xy point they give us. And what we're going to do is we're going to solve for a. We're going to figure out what the a value is. And then once we know the a value, we're going to substitute that in. And then we're going to rewrite it in standard form if necessary. Okay? So let's just kind of go through those steps. It's a function g has a vertex at 1, 1 and passes through the point 0, 2. Write an equation for g of x in vertex form. Okay. So this is what we want to do. So the first thing we need to know is what we have. So the vertex is 1, 1. So basically that tells us this is h and this is k. That's the vertex point. And then they give us a second point on the line, or on the parabola, 0, 2. This is our x and y. 0, 2 is going to be our xy. So this is what we're going to do. We have vertex form, y equals a parentheses x minus h squared plus k. Okay, that's vertex form. We know that. Replace every number you can from these coordinates into that equation. So let's do that. Let's see, do I know y? Yeah, I do. It's 2. Do I know a? I don't. So leave it as a. Do I know x? What's the value of x? 0. So no biggie. 0 minus, do I know h? 1 squared plus, do I know k? 1. Okay, so there it is. I substituted everything I can. Okay, so let's simplify that. I got to do what's inside the parentheses, order of operations. What's 0 minus 1? Okay. Okay. So I got this. I got to square that. Order of operations. -1 squared is, and then 1 times a is just a, right? So I get 2 equals a plus 1. Now just solve that. Figure out what a is. Well, how do I get rid of this plus 1?
-1.
Yeah. So a equals, okay. So this is what I was looking for. I wanted to figure out the value of a. Because now that I know the value of a, I can write g of x in vertex form. Okay? So let's do that. Over here where I'm going to say g of x equals, and remember vertex form is this right here. So where a goes, what should I put instead of a? 1. So I can put a 1 or leave it just blank. And then x minus, what was my h value? 1. And then what was my k value? There it is. There's my answer in vertex form. So that's what I was looking for. Oh, I forgot one thing. What did I forget? There's one very important part I forgot. Squared. Okay, remember there should be a 1 there. If you want to put it, that's fine. If you leave it, normally it's not written, but that's what we hunted for, the a value. There it is. Okay, and these numbers, this one and this one, came from the fact that that's h and k. Okay, any questions? Okay, let's look at the next one. What's the difference in the next one we have to find? Yeah, we want this h of x in standard form. So it's going to be a little more work. But they tell us this is the vertex. So this is h and k. And this is the point that it's going through. So this is x and y. So we start the same way we did before. Okay? Let's plug all that in. So instead of y, I'm going to put 0. Instead of a, well, a I don't know, so leave that as a. And then instead of x, I'm going to put which number? -4 minus, what's my h value? -2. So this minus and that -2 makes this squared, and then plus 8. Okay? Simplify that, please. Start with parentheses. -4 plus 2. How much is that? Okay? Then we got to square -2. That gives us, okay, so 0 equals, this is +4, so it's 4a plus 8. Okay? Let's figure out what a is. What's the value of a? Solve it for a. What number do I get for a? -2. Subtract 8 to both sides, divide by 4. A is -2. Okay? So now let's write our equation in vertex form to start with. So g of x equals -2 parentheses x plus 2 squared plus 8. Okay, so all I did was the a value now is -2, and then x plus 2 because that was plus 2, plus 8. Any questions? But we want this in standard form. So now we got to distribute and do all that stuff. Okay? So let's do that. So the first thing I want to do is x plus 2 squared. So negative 2 parentheses, that's going to be x squared plus 4x plus 4, and then outside the parentheses plus 8. Okay, I just squared x plus 2. Now I have to distribute the negative 2. Negative 2x squared minus 8x minus 8, and then the plus 8. Yeah, we get canceling. These will cancel. So my final equation in standard form is negative 2x squared minus 8x. Okay, and this is what we want. So basically now we can write equations and we can put them in whichever form we want. Standard form or vertex form. Okay. Okay, we got a couple more things we got to do. Okay, so we have this function m of x right here. This is m of x. It's represented by the graph on the right. Write an equation for m of x in vertex form. Okay, so what are the two pieces we need? We need the vertex. What's the value for the vertex? 3, negative 3. Yeah. So the vertex here is 3, negative 3. Then we pick any other point we want. I like smaller numbers. I'm going to pick this point. 1, 1. So this is x and y, and this is h and k. Okay? So what we have to do is figure out the a value. I'm just going to give it to you for time's sake. So m of x, it turns out the a value would equal 1. So the a value is going to be 1. So we went through all that here, how to find that. So the a value is 1. So this would be x minus, what number would go here? Huh? Which number would go here? 3. And then since this is, the k value is negative 3, it's minus 3. Okay? So there it is. So that would be this. So now, if we want this in standard form, again, we would square that and then subtract 3, and we end up with x squared minus 6x plus 6. Okay? Okay. Okay. Let's take a look at number 7. Mr. Turner graphs the function g of x and h of x on the same coordinate grid. The function g of x has a vertex of 2, 10. Okay? And passes through the point 0, 2. Function h of x is that one. Which function has a greater maximum? Okay, so it turns out both of these are going to open down. So g of x and h of x are going to open down. So they're going to look like this. And it's going to have a maximum. So this one here, 210. Which number is the maximum? Is it the 2 or the 10? Yeah. So this H value, the H value is your maximum. It's going to get no higher than 10. Yeah. H for height. That's pretty good. I wonder if that's why they had it like that. Okay. All right. Well, let's look at this other one. What's my HK over here? So the H, I'm sorry, this is the K. What? It's not that. It's K. My mistake. It's K. So K, not H. So we have 4 comma 8. What's the maximum value for this HK, for this vertex? 8. So yeah, we're always looking at these values. So we have G of X has a maximum value of 10. H of X has a maximum value of 8. Which one's bigger? Which one has a, yeah. Okay. Okay, the last thing we're going to do here is look at this function, f of x, and we're going to state if it's true or false. The first one's pretty easy. The vertex, so we're saying the HK is 7, negative 9. Is that true? False. It's actually negative 7, negative 9. Okay. The function's graph will have a range of y less than or equal to negative 9. Remember, this one's going to open down, right? It's going to open like this. Will the y value get any greater than negative 9? So this one's actually true. The maximum point is going to be at negative 9. Okay? And the function is equivalent to this. Turns out that this is false. Okay? Because f of x is actually negative 2x squared minus 28x minus 107. Okay? So that would have been, that's going to be the standard form of this equation. Okay? All right. So let me pass out the assignment.